Delta II is an American space launch system, originally designed and built by McDonnell Douglas. Delta II is part of the Delta rocket family and entered service in 1989. Delta II vehicles included the Delta 6000, the Delta 7000, and two 7000 variants. After McDonnell Douglas merged with Boeing in 1997, Delta II rockets were built by Boeing Integrated Defense Systems, until Delta rocket production became the responsibility of United Launch Alliance on December 1, 2006. ULA now markets Delta II to U.S. government customers, and Boeing Launch Services markets Delta II to commercial companies. Delta II production has ceased. 3 more launches are scheduled and 1 additional vehicle remains unsold. History: all United States expendable launch vehicles were planned to be phased out in favor of the Space Shuttle. After the Challenger disaster of 1986, President Reagan announced that commercial satellites were to be launched by private industry. A contract to provide 20 launch vehicles for the U.S. Air Force, beginning in 1989, brought Delta back into production with Delta II. Delta II was specifically designed to accommodate the GPS Block II series of positioning satellites. Additionally, the Delta II launched several NASA missions to Mars: Mars Global Surveyor in 1996, Mars Pathfinder in 1996, Mars Climate Orbiter in 1998, Mars Polar Lander in 1999, Mars Odyssey in 2001, Mars Exploration Rovers in 2003, Mars Phoenix Lander in 2007. Delta II manufacturing, assembly and integration reportedly take place at facilities in Decatur, Alabama, Harlingen, Texas, San Diego, California, and Denver, Colorado. Vehicle description: Deltas are expendable launch vehicles, which means they can only be used once. Each Delta II launch vehicle consists of Stage I, RP-1 and liquid oxygen tanks that feed the rocket-in RS-27 main engine for the ascent. The first stage is technically referred to as the Extra Extended Long Tank Thor, a derivative of the Thor ballistic missiles were all Delta rockets until the Delta IV. Solid rocket booster motors, used to increase thrust during the initial 2 minutes of flight. The medium-capacity Delta II has 9 motors total. The other models use only 3 or 4. Interstage, a spacer between Stage I and Stage II. The first friction stir-welded interstage module was launched in 1999. Stage II, Delta K stage featuring a restartable hypergolic Aerojet AJ-10-118K engine to insert the vehicle spacecraft stack into low Earth orbit. This propellant mixture is highly corrosive, so once loaded the launch must occur within approximately 37 days, or the stage will have to be refurbished or replaced. This stage also contains the vehicle's brains, a combined inertial platform and guidance system that controls all flight events. Stage 3, optional ATK thecal solid rocket motor for payloads bound for higher energy orbits such as GTO or to reach Earth escape velocity for trans-Mars injection or other destinations beyond Earth. It is connected to the payload until it is done firing, and then separates. This stage is spin-stabilized and depends on the second stage for proper orientation prior to Stage 2-3 separation, but could be equipped with a nutation control system to maintain proper spin axis. It also includes a yaw-weight system to induce tumbling in the third stage after payload separation to prevent recontact, or a yo-yo spin mechanism to slow the spin before spacecraft release, as many spacecraft cannot handle the high spin rates needed for stability of this stage. Payload fairing, thin metal or composite payload fairing to protect the spacecraft during the ascent through Earth's atmosphere. Naming system: the Delta II family uses a 4-digit system to generate its technical names. The first digit is either 6 or 7, denoting the 6000 or 7000 series Deltas. The 6000 series, last flown in 1992, had an extra extended long tank first stage with RS-27 main engine, plus Castor IVA solid rocket boosters. The current Model 7000 series have an RS-27A engine, with a longer nozzle for higher expansion ratio and better high-altitude performance, and GEM boosters. GEMs are larger, and have a composite casing to reduce mass versus the steel-cased casters. In addition, two LR101NA11 vernier engines provide guidance for the first stage. The second digit indicates the number of boosters, usually 9. In such cases, 6 are lit at liftoff and 3 are lit 1 minute into flight. On vehicles with 3 or 4 boosters, all are ignited at liftoff. The third digit is 2, denoting a second stage with an Aerojet AJ-10 engine. This engine is restartable, for complex missions. Only Deltas prior to the 6000 series used a different engine, the TR-201. The last digit denotes the third stage. 0 denotes no third stage, 5 indicates a payload assist module stage with star 48B solid motor, 6 indicates a star 37 fathoms motor. For example, a Delta 7925 has the later first stage, 9 GEM boosters, and a PAM third stage. A Delta 7320 is a two-stage vehicle with 3 boosters. A Delta II Heavy used the larger GEM 46 boosters, originally designed for the Delta III. These are designated 79XXH. The Heavy variant could be launched only from Cape Canaveral, and was retired with the closure of that launch site in 2011. 3 payload fairings are available. The original aluminum fairing, seen above, is 9.5 feet in diameter. A 10-foot fairing is made of composite, and can be distinguished by its tapering front and rear. A lengthened 10-foot fairing is used for the largest payloads. Launch description: Launch vehicle build-up. A Delta II launch vehicle is assembled vertically on the launch pad. Assembly starts by hoisting the first stage into position. The solid rocket boosters are then hoisted into position and mated with the first stage. Launch vehicle build-up then continues with the second stage being hoisted atop the first stage. Fueling. It takes approximately 20 minutes to load the first stage with 37,900 liters of fuel. Delta II launches. The Delta II system has been used for 152 launches. On September 18, 2007, Delta II completed its 75th consecutive successful launch. This is a record for modern launch vehicles. As of 2012, it is the most reliable launch vehicle in service, which it has been since the presumed retirement of the Tsikalen II in 2006. With the launch of OCO-2 in 2014, the Delta II has enjoyed 97 consecutive successful launches. Should the remaining 3 scheduled launches be successful, the Delta II could achieve 100 consecutive launch successes. However, the Delta II system does not have a perfect success record. One mission, the launch of Koreasat-1 in 1995, was a partial failure in which the satellite payload was able to compensate when the launch system placed the vehicle in an incorrect orbit. Another failure, this time complete, occurred on January 17, 1997, when a Delta II 7925 carrying the first GPS Block IIR satellite, GPS IIR-1, exploded only 13 seconds after liftoff, raining flaming debris all over Launch Complex 17 at Cape Canaveral Air Force Station. No one was injured, and the launch pad itself was not seriously damaged, though several cars were destroyed and a few buildings were damaged. It was later determined that a 17-foot crack in the rocket booster had caused the failure. Notable payloads. Furthermore, between May 1997 and November 1998, Delta II vehicles placed 55 Iridium satellites into orbit. Post-MLV-3. A 2007 article published by the Wall Street Journal speculated about the fate of the Delta II launch system after the U.S. Air Force discontinues its use of the Delta II. Thomas Young, who was director of Goddard Space Flight Center from 1980 to 1982, is quoted as saying, "It's definitely an item people are quite worried about." As of July 2014, 3 further Delta II launches are scheduled. Carrying the SMAP satellite in November 2014 and the JPSS-1 and ISAT-2 satellites in 2017 and 2018. ULA had previously indicated that it had around half a dozen unsold Delta II rockets on hand. A spokesperson indicated that ULA will change some aspects of the Delta II system once the current Medium Launch Vehicle 3 contract with the Air Force ends and requirements imposed by the contract are lifted. The Air Force contract required the Delta II be kept ready to launch within 40 days of call-up, which led ULA to maintain 2 launch pads at Cape Canaveral. ULA indicated it would not continue to operate 2 launch pads. In August 2009, the NASA Assistant Associate Administrator for the Launch Services program stated that NASA might purchase additional Delta II launches beyond those it had planned at that time. However, on September 30, 2011, NASA modified the NASA Launch Services 2 contract to allow for the continuing order of Delta II launches in agreement with ULA. Components for 5 additional Delta II vehicles had been built and 2 now remain unassigned to planned flights. Under the terms of the revised NLSII contract, only 3 Delta II configurations are available: the 7320-10, 7420-10 and 7920-10 and launches are only available from SLC-2W at Vandenberg Air Force Base. ULA has continued to update its product website and continues to state that the vehicle is available for order for commercial or government offices. On July 16, 2012, NASA selected the Delta II for the launch of Soil Moisture Active Passive, Orbiting Carbon Observatory 2 and Joint Polar Satellite System 1 spacecraft. The spacecraft will launch in October 2014, July 2014 and November 2016, respectively, aboard Delta II rockets from Complex 2 at Vandenberg Air Force Base in California. Comparable rockets: Ariane 4, Delta IV, Falcon 9, Long March 3B, GSLV, Soyuz U, Antares. See also, Comparison of orbital launchers families, Comparison of orbital launch systems, references. External links, media related to Delta II at Wikimedia Commons. Delta II page at Boeing.com, Delta I-213 launch data at Skyrocket. History of the Delta launch vehicle.